IGCSE Computer Science, Syllabus Statement 1.1.2f, Identify Current Uses of Hexadecimal Numbers in Computing. So, we've gotten up to the point where we've learned how to convert hexadecimal numbers to and from decimal and binary, and we've also looked at how hexadecimal is easier for programmers to read rather than reading binary. So now we've gotten on to the last statement of this, of hexadecimal, and this is the uses, like the actual uses of it. Like, you might already know a few, like HTML, MAC addresses. They all use hexadecimal, so that's basically what we're going to be covering in this video. So we'll start with memory dumps. So memory dump is a process in which the contents of a memory are displayed and stored if an application or system crashes. And it's used to help programmers identify and fix the problems which cause the crash. So a memory dump kind of looks like this. So basically, the values here, the contents, and the values here are the locations. So a programmer can look at this and find where an error is. So left values, again, are the memory locations, and this makes it easier to actually find where the problem lies. HTML, Hypertext Markup Language, which is what HTML stands for, if you didn't know, is used in development of web pages. Note that this isn't a programming language, but a markup language. And a markup language is used in the processing, definition, and presentation of text. HTML uses these tags, which are used to bracket code. For example, title starts the title of an HTML document, and /title is used to end it. For example, title, hello world, title, or /title rather. So that would title the HTML document. HTML is also used to represent colors on the computer screen. The three primary colors, which are red, green, and blue, are used to represent secondary colors. So you mix them up and they make secondary colors. And the intensity of each of these colors is determined by a hexadecimal value, hashtag RRGGBB. So this is where hexadecimal is sort of tied into HTML. So hashtag FF0000 would be the primary color red, that would be green, that would be blue, and of course you can mix them and give them different intensities, that is hexadecimal values. For example, FF00FF would give this pinkish color, D42460 would give that color, 00C4FF would give that color, 5B9C25, and so on. So here's an example of what an HTML document looks like. So this is one I created last year, and this is Scott's page. And you can kind of see through the tags what these different things do, like what actually happens. So, like for example, body. You can just read the word and know that it's sort of the body of the page. And BG color is, of course, background color, and it's a hexadecimal value here. And as you can see here, it's 0000FF, which means it's primary blue. And this would be green here. And that would be, well, the title on the page. So H3 is sort of like header 3, and that's kind of a big thing on the top. And this is basically importing an image. Alt is it stands for alternative, and that basically means that if the source can't be found, then the word Scott will be printed instead. MAC, Media Access Control Addresses, basically. It's a unique hexadecimal number which identifies a device on the internet. And it's usually made up of 48 bits, kind of like this, or like this. The 6 ends in the front is the OUI, or the organizationally unique identifier, and the 6 Ds is the UAA, or the universally administered address. So basically, the OUI is the vendor number. For example, Apple's vendor number is this, Microsoft's is this. So basically, it's sort of the company number. So like all of, say, Apple's devices, their MAC addresses will start with this, or rather, this. So for example, it would kind of look like this. The UAA is the device's unique serial number, which is set by the manufacturer when it's created. So like in an Apple factory, if you're making an iPhone, that's where it's set. But a user or company can change this into a locally administered address. So this new address will override the original UAA, but it must be unique, which is why doing this is uncommon. So basically they have to be quite careful that it is unique, you know, in case something can go wrong. So why change it into a locally administered address? Well, certain software needs all MAC addresses of devices to be a certain format. It may be required to bypass a MAC address filter on a router or firewall. So basically, if like a firewall has restrictions, as in like it allows only certain allows only a certain type of MAC address, then you'll have to change that into that type in order to bypass it. And also to get past certain network restrictions. So like MAC address may need to be a certain format to connect to that network. Web addresses. Each character on a keyboard has an ASCII value, or an ASCII. And these codes can be represented using decimal or hexadecimal. So here's a sort of an ASCII table here. So you can see all the characters and their decimal and hexadecimal values. So like D would be 44, and well, capital D that is, and lowercase would be 64, and so on. Some of the characters are here as well, like the special characters. So an example of the use of ASCII is the representation of a web address, or URL. So like Facebook would be this, and % is used to denote that hexadecimal is being used. So here I have a program which will convert a website that you type in into the hexadecimal form. So if we give this a try on, say, Google, it'll give us this. So we copy that, and you can paste this into your browser and enter. It should take you to Google. So let's try another one. So, like Facebook. We get that. Paste it in. Enter. So you can see it works. That's pretty much how that works. And our final use is assembly and machine code. So, computer memory can be referred to directly using machine code or an assembly language. So if we take the line in assembly LDA number 12, so basically that means load into accumulator number 12. Well, in machine code hexadecimal, it would look like this. But machine code binary would look like this. So basically, we're going to be learning about assembly and machine code in another topic, but like here we need to focus on the hexadecimal. So basically what this example kind of shows, or it's supposed to show, is how like if we have like, I mean, one line, sure, it's quite small, but like if we have multiple lines of like machine code of binary, that is, like it can be really hard to actually program in machine code. So that's why hexadecimal is usually preferred by programmers to use rather than binary, because like if we have a bunch of zeros and ones, it's gonna be really hard to actually like find, troubleshoot, program, and just etc. all of that. So it's much easier in hexadecimal, and you can sort of easily find errors and just program in general.